places in space between the Earth and the Moon called the libration points. And these are places basically where the gravity from the Moon and the gravity from the Earth cancel each other out, and an object placed at that location remains there and doesn't drift off.
What propulsion system could be used to reach the stars? For starships, it's antimatter. This, the equal and opposite of matter, can be made in enormous atomic accelerators by smashing normal atoms together.
I first became interested in space travel about 10 years ago. I had, before that, been doing experimental particle nuclear physics, thinking at odd moments about how we could use the results of that research to make spacecraft fly. The challenge for the next generation of rockets is to go into deep space. That is, to explore the outer planets, then to go into interstellar travel. Chemical rockets simply do not contain enough energy per pound of fuel to enable those missions.
The amount of antimatter in a matchbox could replace a boxcar of traditional nuclear fuels for powering spacecraft. But until recently, there wasn't any way of taking antimatter to your rocket.
It's a prototype instrument which we are just completing. It's designed to trap and hold 10 billion antiprotons for a period of up to 10 days. Our plans are to manufacture a much more substantial trap, but will handle up to 1,000 billion antiprotons. That number is significant and will allow us to trigger microfusion reactions with the antiprotons. And in turn, that would enable robust space missions. We're talking about very fast missions to Mars with a very substantial spacecraft delivering perhaps 100 metric tons to the surface of Mars with several astronauts in a very quick period of time, round trip 120 days.
So antimatter suspended by magnetic and electric forces in supercooled thermos bottles could be the fuel for massive space liners. Once a second, the antimatter would detonate an explosion like a tiny hydrogen bomb.